solutions GS has developed over the years for various power unit requirements. A new product from some of our suppliers enables us to put VFDs driving the electric motor that drives the pumps. With some of the new pumps, we can have a speed range from 200 RPM to 3,000. It allows us to fit smaller pumps into applications, reducing the required torque, and allows us to still give high peak speeds. So we end up with a proportional solution from simple bang-bang valves. That allows the system to perform better, to use less energy, and give more precise control. Many applications require a very high starting torque, but when they're actually running at speed, conveyors, or if you're positioning, the ability to use an on-off valve, and one example would be to operate from 1 gallon a minute to 15 gallons a minute. When I have to precisely position, or I'm trying to stop at a particular point, the ability to ramp down to a low speed and still use an on-off valve, no proportional electronics, no radio interference, anything else like that going on, because it's at the motor that's being driven at the hydraulic pump. Those are particular applications where this can make a giant leap forward. And with the cost of variable frequency drives in the smaller horsepowers, 10 horsepower and under, it's always something that should be looked at. It does make a big difference in many applications. We've got applications on biodigesters where they have to run pumps with hydraulic motors because of the environment. They end up 40 and 50 horse. A lot of those cases we dropped 50 horse applications down to 40. We eliminated heat exchangers because the system became more efficient. We've got more than 40 years experience with the drives and how to apply them. There's some clever things with the drive. If you run into too big a load, rather than popping off a relief and stopping, the VFD will slow down from 90 hertz to 60 hertz. In 3 or 4 milliseconds it can slow down. If it isn't properly sized or programmed, the drive may take you all the way down to 0 speed. You don't stop, because any process that stops dead really messes up the whole system. It takes a long time to reinitialize a system if one intermediate component stops, and then the whole thing behind has to stop. It's our experience of applying these drives on an infinite number of problems we've addressed, and that expertise allows us to very quickly cross-pollinate from this solution 12 years ago to that'll help me here today.